All right. Good afternoon again, everybody. So, yeah, thank you for waiting. Dinouble check ko yung recording natin. And Matthew is right. Thank you, Matthew. Nasimulan natin yung proof ng Theorem 1.4. But essentially, what we have proven is one of the key results that we will need in the proof of Theorem 1.4, right? One of the, the tool that we will rely on for for the proof of Theorem 1.4. But before that, I hope you have already seen your graded homework one. So, na-checkan ko na yung homework one. Kindly take note of my comments there. Kung di nyo maintindihan yung comment kasi pangit yung sulat, pakisabihan na lang ako and then I can clarify things for you. If you're not sure why some points were taken off or you're not sure what's the right thing to do or you want to clarify something, just let me know via email. And one thing is medyo graveyard shift pa rin ang body clock ko. So usually grade in the wee hours of the morning. Kung gising pa kayo kagabi, probably you got notified by Canvas around, ano ba ako nagsimula mag-check kagabi? Parang around midnight to 2 or 3 a.m. So kung ayaw nyo na-istorbo during those times, please turn off the notifications na lang nyo kay Canvas so that you don't see it. Or if you don't want to bother looking for the settings, pwede namang ignore nyo na lang. So I'm not expecting replies during those times. And ano lang naman siya, notification that your homework was already graded. Okay? What else? I think that's it. So we can probably start our discussion proper. Nakalimutan ba akong sabihin? Okay, parang wala naman. All right, so last week we started the course and we said one of the goals, or actually the main goal of chapter 1 is to axiomatize the set of real numbers that we know. So we have learned several things about it. So we started our axiomatization by assuming that there exists a set containing all the real numbers, but we didn't give any characterization on the set of real numbers just yet. So we considered it as an undefined term. And then we introduced two binary operations, which are also abstract in nature, because I didn't teach you how to multiply or to add the two real numbers. All we know about these operations is that these are binary operations. You take two real numbers, you can add them, you can multiply them, and you get another real number back. Okay. And then I lay down all of the properties that I want, the basic properties that I want that these operations together with the set of real numbers to satisfy. Okay, meron tayong A1 hanggang A9. So these are usually called or in the lecture notes, these are called the algebraic actions, but they can also be referred to as the field actions because you will learn later in modern algebra that any non-empty set together with two binary operations satisfying A1 to A9 is called a field. So our prime example of a field is the set of real numbers. Okay? So ito yung mga properties na gusto nating masatisfy nung kung ano mang addition at multiplication yung i-define natin, which is a departure from the pragmatic approach in our earlier years wherein we were taught first how to add and multiply two real numbers before deducing all the properties of these operations and the set R. All right. And then during the course of discussing these axioms, we met actually two real numbers already. So we met 0 and 1, which are actually the additive and the multiplicative identities of the set of real numbers. Okay. And then they are just random assignments of symbols. So tinawag lang natin na symbol 0, yung additive identity, symbol 1, yung multiplicative identity, all right? And we will further assume, or we will say that it can be proven actually that 0 is not equal to 1. So at least we have two distinct real numbers on our hands right now. And you are not yet permitted to give me another real number. Kasi ito pa lang, yung dalawang real numbers na alam natin from before. And then what else? Yeah, we went through properties A1 to A9. And then yun sa homework, may pinasagutan ako about some properties about it. And then we look into some special subsets of R, right? So sinimulan natin sa set of natural numbers. And again, the construction of the set of natural numbers axiomatically can be found by reading your Math 101 notes. Gumamit tayo dito ng Piano's Axioms. All right. And I said I will not dwell on the axiomatization of these numeration systems. Pero may mga nagtatanong kasi na curious sila kung paano siya nabuo. So yung N, nabuo siya sa 5 Piano's axioms. So go back to Math 101, you will see the listing of Piano's axiom there. And then the other real numbers can be defined out of necessity para masatisfy yung mga field axioms. For instance, in Piano's axioms, there is one that will imply that there is no number added to one that will give us 0, because 0 is not a successor of any natural number. So ibig sabihin, wala tayong kayang i-add halimbawa kay 1 para makuha si 0. That means si 1, hindi siya magkakaroon ng additive inverse. But we want our set of real numbers to have an additive identity. Or actually, not an additive identity, but will have additive inverse for each of the real numbers. So, alam natin na kulang yung n. Hindi kompleto yung n in the sense na hindi siya yung pwedeng maging real number system kasi kulang pa siya ng miyembro, specifically the additive inverses of the natural numbers. So we need to invent some symbols for these. Tapos sinawag natin siyang -1, -2, -3, and so on. Tapos isasama ko si 0. Tapos i-union ko siya sa n. So this is our next candidate para maging set of real numbers. However, the problem here is that using the statements in Theorem 1.3, hindi tayo magkakaroon ng multiplicative inverse para sa lahat ng mga elements ng set na to. For instance, 2 is a natural number, and yet its multiplicative inverse is not within this set. So that's why we concluded this cannot be, or this current set that we have cannot be the set of real numbers. Kulang pa siya. Tawagin natin siyang set of integers. Okay? So palaki siya ng palaki. Pero alam natin kulang pa rin yan. Hindi siya pwedeng maging R kasi mabaviolate niya yung A8, the existence of multiplicative inverse for all non-zero real numbers. So kailangan nating magdagdag. So halimbawa, kailangan ko idagdag si 1/2, si 1/3. So 1/2 for now is the multiplicative inverse of 2. And we know that that multiplicative inverse does not reside on the set Z. So kailangan ko siyang idagdag. Kailangan ko ring idagdag si 1/3. Kailangan ko ring idagdag si -1/3, and so on. So marami akong kailangang idagdag. But hindi ako makokontento sa mga numbers of the form 1/A, where A is a non-zero integer. Kasi paano naman yung closure under multiplication? Remember, pag nag-multiply tayo ng dalawang real numbers, dapat yung sagot ay real number pa rin. So, ibig sabihin, halimbawa, si 3 real number yan, nasa n nga siya, which is the subset of R. Si 1/2, sabi natin, dapat maging member ng R kasi siya yung multiplicative inverse ni 1/2. But if I multiply these two guys, I will get 3/2 using the usual multiplication that we know. So ngayon pala kailangang matutunan na natin kung paano mag-add at mag-multiply. So now you can assume the usual arithmetic. So pwede nyo siyang gamitan anywhere in your proof. So you can say without proof that 3 times 1/2 is equal to 3/2. But the point here is that kailangan pala si 3/2 nasa set of real numbers pa rin. Okay? So ibig sabihin pala, my next candidate para mag-consist ng set of real numbers is the set containing all those ratios of integers. So set of all m/n, where m and n are both integers, but n is not equal to 0. Now this is my candidate for the set of real numbers. And for centuries, people believed na kompleto na ito na yung set of real numbers. Any real number can be written as a ratio of two integers. Kaya lang, the Pythagoreans were able to prove axiomatically that that's not the case. Kulang pa ito. You can call it the set of rational numbers, but there are some real numbers that are not rational. And our example for that is square root of 2. All right? And I think this is where we stopped last time, or actually we already started the claim of the proof of the claim. that we will use for the proof of Theorem 1.4, the irrationality of square root of 2. And that statement is this. If a squared is even, then a is even. Actually, hindi pala to dapat r, no? Dapat ito ay integer. So if you have an integer a that is even, you have an integer a such that a squared is even, then a is even. Then we prove it using a nice tool kasi mahirap yung direct proof. Gumamit tayo ng proof by contraposition. Okay? So essentially, siya yung ginawa natin last week. So moving forward, unless you have any questions, ipoprove na natin, punta na tayo sa main result. Ipoprove natin that indeed square root of 2 is irrational. Okay, let me write that here. Okay, now the proof will be a contradiction argument. So mahirap kasing i-prove siya directly. So paano mo ba ipapakita that Q is not rational in a direct fashion? If you want to do it directly, you need to show that Q cannot be written as a ratio of two integers. And actually, proving a negative statement is quite hard because kailangan mo talagang ipakita without any shadow of doubt na hindi siya kayang isulat as a ratio of two integers. If we are not able to find two integers, that doesn't mean that walang ganong ratio na magbibigay sa atin ng square root of 2. It's just that baka hindi natin siya nakita. That's why direct proofs for statements like these, like this, is very hard or very difficult. So what we'll do is use reductio ad absurdum or proof by contradiction. And again, in a proof by contradiction, we will assume that the statement to be proven is false. Parang ganito yung idea. Pagpalagay natin na mali siya. Kung mali siya, kailangan tayong makahanap ng isang contradiction. Something that will contradict a previously established fact or a previous assumption. Okay? So assume mo na mali yung theorem, ipakita mo na something will be wrong, something unacceptable will happen if the theorem is false. And the law of excluded middle will tell us na, okay, dahil hindi siya pwedeng mali, dapat tama siya. All right? So yun yung idea ng proof by contradiction. Now, we want to prove that square root of 2 is not rational. So we will suppose, for the sake of contradiction, that square root of 2 is rational. Okay? So yun yung idea. And then we want to derive a contradiction. The problem with proofs by contradiction is wala tayong gabay kung saan tayo pupunta. So you can use valid arguments leading to anywhere as long as at the end of the tunnel, makakita ka ng contradiction. Hindi katulad ng direct proof na magsisimula ka sa assumption, unti-untiin mo, gusto mo makarating dun sa conclusion. Meron kang definite na target. However, sa proof by contradiction, ikaw yung maghahanap ng contradiction. Alright? So wala tayong specific na target na makuhang contradiction. Okay? So that's one drawback of proof by contradiction. But the idea, assume that the statement to be proven is false. Kunwari mali siya. And luckily, we only know a little amount of information. Kokonti pa lang yung alam nating mga theorems, mga facts, and so on. So there is little wiggle room kung saan tayo pupunta after assuming that square root of 2 is rational. Okay? And can anybody direct me to that line or to that statement? Ano kaya yung susunod? Ano yung pwede kong sabihin? Sige, pagpalagay natin na si square root of 2 ay rational, then what will happen? Or what can we say about it? Volunteers? Yes, Perlene?
Kapag po inassume natin na si square root of 2 ay rational, ibig sabihin po, pwede po natin siyang masulat sa m over n, where n is
Okay.
not equal to 0.
All right. Thank you, Perlene. Nakita ko naging careful ka doon, no? So that's a good sign. Yeah, she's right. Kapag kasi square root of 2 ay rational, then there exist two integers, m and n, with n not equal to 0, such that square root of 2 is equal to m over n. Okay? And then this is a trick that I'm going to do. I will not just simply assume that there are integers such that square root of 2 is equal to m over n. I will assume that m over n is in lowest terms. Okay? Meaning, wala nang common factors si m at saka si n. Kaya naka-lowest term na siya. Okay? And I can do that because if m over n is not in lowest terms, then I can rewrite it as m star over n star, where I already canceled out the common factors between m and n. Okay? Kaya without loss of generality, kaya kong sabihin right away na si m over n kunwari naka-lowest terms na. Kasi kung hindi pa nga, kaya ko siyang i-lowest terms. Yun na yung pipiling kong m at saka n. Okay? Agree so far? All right, I hope you do. Kung may objections, just raise your hand. Okay. And the next, dahil may fraction, may square root, ayoko mag-work with square roots, so I can say that by anong bang pwedeng gawin? By multiplication property of equality, we have 2 equals m squared over n squared. All right. Or that's equivalent to saying that 2n squared is equal to m squared. Now, what can I say about this line? Or what can I infer from this line? So at this particular line, we are saying that m squared is equal to 2n squared. So what can I say about m squared? Yes, Jonathan?
We can say, sir, that m squared is a multiple of 2.
Or better yet,
Or
restatement lang.
Yung p po ay must be a multiple of 2.
All right, so okay.
Ay, sorry
Ayaw
pala.
mo diretso ito.
Nandito po ako sa
Pero tama naman, si m squared ay multiple of 2, right? Yeah, that's perfect. Pero may nahanap akong term eh. Pero nandun ka na.
Sige po. Noted po.
Yep. Sige, Ana. Pero tama yung sinabi mo, Jonathan. Yes, Ana?
M squared is even po.
Alright, so tama. So, tama si Jonathan, pero gusto kong gamitin yung term na even para ma-apply ko yung theorem na pinrove natin towards the end of Thursday's class. So, m squared is even, alright, because it's a multiple of 2, as Jonathan said. Then, what's the deal if m squared is even? Can another of you help me with this? Eh ano ngayon kung si m squared ay even? Yes, Jabel?
If m squared is even po, then m is also even.
Okay, great. And paano ka nakasigurado na totoo yun? Alright, ito yung pinrove natin last time, right? Ito yung claim na pinrove ko before this statement. So, okay. And then so far, it's still good. We haven't violated any of the principles or assumptions or theorems that we have before. So we know that m is even, okay? So kung even siya, okay, parang wala akong mahihitang contradiction doon. Okay. Then what can I say here? Sige, magpapatuloy pa ako kasi wala pa ako na-derive na contradiction. Now, m is even. So therefore, I can write m. So hindi ko pa pala ito lalagyan ng period kasi hindi pa ako tapos. Si m daw ay even, so mag-continue lang ako. So si m, pwede kong maisulat as 2p for some integer p, right? Kasi even siya. So equal siya kay 2p for some p. Hindi ko lang si p, basta meron nag-exist na p, right? So far, still good. So I'm going to use equation star here. I'll go back to star because now I have a simpler expression for, or now I have another expression for m. I can write m as 2p. So from star, I have 2p squared or quantity 2p squared kasi dito papalitan ko si m ng 2p. So I'll have 2p squared, which you know is equal to 4p squared, ay equal daw kay 2n squared, right? So plug in m equals 2p there, you'll get 4p squared equals 2n squared. And then from there, I can divide both sides by 2, or I can use the associativity and then cancellation law. You'll get what? N squared? equals 2p squared. All right? And then what can I say from there? Ano yung pwede kong masabi mula sa linya na yon? Tama ba yung arithmetic ko? All right, I think so. So ano masasabi ko about n squared? Okay, Matthew?
I think masasabi mo ring even yung n squared.
Okay, great. N squared is even because it's 2 times another integer. Remember, p is an integer, so p squared is another integer. And then what's next, Matthew?
That also means from our previous proof na n is also even.
Okay, great. So n is also even. And here, I will put the Harry Potter symbol or the Blitzkrieg, all right? Na meron na akong contradiction. And can anybody explain to me why there is a contradiction? Yes, Rezi?
Yung M over N po ay sinabi kanina na naka-lowest lowest term. Pero may
Okay.
may multiple pa po silang 2.
All right, that's perfect. That's right, Rezi. That's the contradiction. So here we are saying that contradiction, then M and N has 2 or have 2 as a common factor, have 2 as a common factor. So ito yung magiging contradiction. So if we will accept the fact that the square root of 2 is a rational number, then we should be ready to accept that there is a number that is in lowest terms pero hindi pa siya naka-lowest term, which is kind of absurd. So we cannot accept that, so we will agree to accept the negation. All right? Kasi hindi pwede maging mali yung theorem, so dapat totoo siya. So therefore, we conclude that square root of 2 is not a rational number. And we can end the proof there. Okay? Satisfying ulit. Meron tayong black box sa dulo. Okay? And this is a nice result because gagamitin ko pa rin siya later, pero it's a nice illustration of a proof by contradiction. And perhaps you will see this twice or thrice in your classes because this is a very classic one na kahit siguro estudyante na alam ang square root of 2 at saka alam ang add at saka even, matututunan na nga, hindi nga siya pwedeng isulat as a ratio of 2 integers. Okay? So that completes section 1.3. So I guess you don't have any questions. Wala naman nag-react violently. So if that's the case, then I'll go ahead and go to the order axioms. All right. So this will be another set of axioms, actually a pair of axioms. Iba na siya dun sa field axioms. Okay. So ito naman yung magsasabi sa atin, paano natin pwedeng i-order o ihilera in a particular fashion yung mga real numbers. Okay? Kasi ang alam pa lang natin ngayon, paano mag-add, paano mag-subtract, paano mag-multiply, at saka ano yung itsura ng mga real numbers. Right? So yun na yung pwede nung i-assume mula sa elementary. So kunwari, marunong na tayo mag-add, marunong na tayo mag-multiply, marunong na rin tayo or kilala na rin natin yung itsura ng mga real numbers. So yun yung pwede nyo nang i-assume ngayon. Right? Kaya lang, wala pa tayong konsepto ng order. Sino yung mas malaki, sino yung maliit, sino yung nauna sa listahan, sino yung nahuhuli. So the order actions will take care of that for us. But before that, we will define a set, a special set of real numbers or a special subset of the real numbers. Tatawagin natin siyang set of all positive real numbers. Okay? Now, this will be denoted by curly P, right? Tatawagin ko siyang set of positive numbers, but remember, we don't have any notion of a positive and negative number yet. Yung sinusulat natin na -1, -2, hindi sila mga negative numbers per se because this is supposedly the first time that we will see positive the terms positive and negative. So yung -1, -2 notations natin sila para sa additive inverse ni 1 at saka ni 2 respectively. But other than that, we don't have any other interpretation about -1, -2, and so on. Right? Ngayon pa lang natin siya bibigyan ng ibig sabihin. So for starters, we will just get a subset of the set of real numbers. Tatawagin natin siyang set of positive numbers. And then we will provide axioms or rules para magsabi sa atin sino yung mga positive at saka sino yung mga negative real numbers. And they are A10 and A11. Okay, let's take a look at them one by one, starting with A10. A10 is usually called the trichotomy action. Kaya siya tri, ibig sabihin tatlo. Cotomy, usual suffix for choice, all right, or cases. So there are three options now dito sa trichotomy action. If you get a real number A, then exactly one of the three options should be true. A equals 0. A is a positive number, or A is an element of the set of all positive real numbers. So pag element siya ni P, pwede natin siyang tawaging positive numbers. So si A ay positive, o kaya yung additive inverse ni A, siya yung positive. Right? Either A is 0, A is positive, or the additive inverse of A is positive. Okay? So yun yung rule natin para yun yung unang rule para sa determination kung sino ang positive real numbers at sino ang hindi. Alright? Kaya lang kulang pa yan. Kasi hindi siya nagsasabi ng membership. Kinagaranti niya lang na hindi ka pwedeng maging positive and at the same time maging positive din yung inverse mo. Si 0 hindi rin positive. Okay? So, paano natin ma-operationalize yung pag-check kung positive ba siya or hindi? The key is axiom 11. Okay? Sinasabi ng axiom 11, pag kumuha ka ng dalawang positive real numbers, and then you get their sum, and you get their product, then those two results are also positive real numbers. So yun yung katangi-tanging rule. Dapat, pag nag-add tayo ng dalawang real number, dalawang positive real number, ang sagot dapat positive real din. Pag nag-multiply tayo ng dalawang positive real numbers, dapat yung sagot positive real number pa rin. And you already know this, all right? So these are properties of addition and multiplication that we know before. Kaya lang ngayon, nauna yung pag-impose natin ng rules. Kasi dati, meron na tayong notion. Sino yung mga positive, sino yung mga negative. Kaya lang ngayon, we're starting from scratch. Iba yung development na dinaanan natin. Ina-assume natin ngayon, marunong na tayo mag-add, marunong na tayo mag-multiply, pero wala pang konsepto ng positive. Ngayon yung axiom 11, yung magsasabi sa atin na dapat, kung talagang maganda yung addition at multiplication na dinefine natin kay R, dapat ang sum at product ng dalawang positive real numbers ay positive pa rin. Okay? So I hope that is clear. So ito, unti-unti nang mabubuo yung real number system that we know from elementary. Okay? And then since we have just been talking about positive real numbers, let's give a meaning. Ano yung kailangan para maging negative? Well, we say that the number A is negative if its additive inverse is positive. Okay? So with this remark or with this note here, we can redefine or we can restate the trichotomy action. The trichotomy action can then read that either A is 0 or A is positive or A is negative. So yun yung tatlong posibilidad, which is probably the more familiar form of the trichotomy action for you guys. Okay? Okay, meron na tayong konsepto ng positive at saka negative numbers. Now, let's talk order. Pag-usapan or mag-define tayo ng isang order. Paano natin ililista yung mga real numbers so that one will precede another or one will follow another real number? And we will use the less than, the greater than, and their derivative relations. Okay? And that's in definition 2. Let's see, definition 2. We say that A is less than B if and only if B minus A is positive. Okay? So, but remember, subtraction is carried out, or actually it is an addition in disguise. So yung B minus A, this is actually B plus the additive inverse of A. All right? So, pwede daw nating sabihin na si A ay less than B kung yung B minus A ay positive. All right? Which is actually parallel to what we know, right? So A is less than B kasi pwede daw tayo mag-subtract ng B from both sides. A minus B is less than 0. Or B minus A is greater than 0. Probably I wanted 0 less than B minus A. Okay? Ito yung alam natin na konsepto ng pagiging less than. Kapag ka positive yung B minus A, which is essentially what I am codifying in this statement. Alright? Kaya lang, ito pala, careful. Hindi pa natin alam na mga positive numbers ay yung mas malalaki kay 0. Ipoprove pa lang natin siya mamaya. Basta ang alam lang natin, positive siya kung ang sum ng dalawang positive ay positive at ang product ng dalawang positive ay positive. Tapos A less than B kung positive si B minus A. That's the only thing that we are assuming right now. So actually, we don't know how to compare two real numbers yet. Or kung paano natin ma-check kung siya ay positive o hindi. A10 and A11 yung magiging key paano natin ma-determine yan. Okay? But before going any further, let's define the other derivative relations. Okay? So we say that A is less than or equal to B if and only if either B minus A is positive or A is equal to B. And then A is greater than B if and only if A minus B is positive. And then A is greater than or equal to B if and only if A minus B is positive or A equals B. And you will see that these are the common notions. Yun nga lang, medyo mas abstract yung pagtingin natin. All right? And then there's sort of a symmetry. If you say that A is less than B, then that is equivalent to saying that B is greater than A. And also, A is less than or equal to B, if and only if B is greater than or equal to A. All right? So everything's good so far? Medyo marami-raming definitions nung dadaanan natin. Kasi nga, pinapakilala natin paunti-unti. Pero yung real number system. Okay? Now, problema, wala pa tayong examples. Sino yung mga greater than, sino yung mga less than, and so on. So let's look at some results that will enable us to deduce some of the things that we already know. And they are in Theorem 1.5. So I have 8 statements here. Probably will prove a couple of them. And then siguro baka dito ako pumili ng ipapa-homework. By the way, according to our course timeline, meron tayong homework which will be due on Monday again. I'll give it on Thursday. But it would be a great exercise if you can try to answer some of the things that we'll skip. Kasi baka sila yung lumabas sa homework, edi ready na kayo para sa homework. Okay? Now, let's look at these. Probably I'll prove statement 1. And then the first half of statement 6. If you have some requests kung alin yung ipoprove, just let me know. Pero, yeah, just let me know kung meron kayong gustong i-prove. Pero these are my plan. And probably, I'll pick one of the homeworks. I'll probably pick one of these as your homework. Probably, okay? No guarantees nga lang. All right, let's try to prove the first statement. Okay. But let's see what is it saying. So it's we are assuming that A, B, and C are 3 real numbers, okay? And then if A is less than B and B is greater than C, then it says that we are sure that A is less than C. So ito yung transitive property ng less than relation. Okay? So paano natin siya ipoprove? Again, the only tool that we can use would be those that were previously defined or assumed or proven. Okay, yun lang yung pwede natin gamitin. So, but this is a conditional statement. So, we can use the antecedents. Ito yung assumptions natin. Pwede natin siyang gamitin. And the goal is to come up with the conclusion. So, probably I'll start there. So, I will assume that A, B, and C are real numbers such that A is less than B and B is less than C. All right? And then I always find it helpful to know exactly what I am trying to get. Okay? Para alam ko yung target natin. So usually, pag medyo mahirap yung proof or hindi ko pa alam kung paano ko siya ipoprove, sinusulat ko yung WTS, kung ano yung gusto kong ipakita. We want to show that A is less than C, which is still kind of abstract. So dun sa WTS statement, i-enclose nyo lang siya ng bracket or clearly say it's WTS para alam ko na hindi nyo siya ginagamit sa proof. Sinulat nyo lang yung gusto nyo ipakita. Alright? So ano nga ba yung ibig sabihin ng A less than C? Can anybody remind me? What does that mean? Gusto ko siyang i-operationalize. Isulat in a more useful, in a more useful expression? Yes, Tristan?
Hello, sir. Rinig po ako.
Yep, go ahead.
A less than C is equivalent po to saying C minus A is an element of ano po, curly P or ano, positive real number po.
Okay, perfect. Thank you, Christian. Thank you then kay Charles who answered in the chat. That's correct. The only thing that we know about A being less than C is that it is equivalent to C minus A being an element of P. All right. And it's great that you guys didn't write C minus A is greater than 0 because we don't know that being greater than 0 means a number is positive. All we know is that A less than C is the same as C minus A is positive. Okay. Now, paano ko 'to ipo-prove? So, ito yung gusto kong malaman. Luckily, pag direct proof, usually gagamitin mo lang yung assumptions para makarating doon sa conclusion. So, we can also do the same thing and interpret the assumptions. So, I can say here from the assumptions. Okay. Remember, our first assumption is that A is less than B. So, gamitin ko lang yung sinabi ni Tristan at ni Charles kay A at saka si B. Ibig sabihin yan ay si B minus A ay element ni P. And C minus B is also an element of P. All right? So those are the information that we got from our assumptions. And then look at what we have so far. We have B minus A in P, C minus B in P. But I want to get to C minus A being an element of P. So how can I use this information in order to get to the WTS? Any suggestion paano ko makakarating ng malapit dun sa WTS? Okay, Tristan, I'll just wait for somebody else who haven't recited yet. Anyone else other than Tristan? Si Tristan na lang yata yung gising. Sige, Tristan.
Ayun po, sir. We will utilize A11 po. Where ano po, since B minus A is bali po ano, ipag-a-add sila and that would mean na yung result po is an element of the positive real number. Ayun lang po, sir, by intuition.
All right. Yeah, that's perfect. Right? Yeah, tama 'yon kasi siguro nakita ni Tristan na B minus A na to C minus B na to. Tapos gusto ko makarating sa C minus A. So why not add these two guys? All right. So now I can say note that probably I'll write it this way. C minus B plus B minus A equals C plus B minus B minus A. Here I used associativity and probably commutativity as well, right? So sabihin ko na A1 and A2 yan. Tapos ito ay equal to C minus A by what? By A4. Sorry. Yeah, A4 yata yun. Existence of additive inverse, all right? And then what can I say here? So nasabi na yata to ni Tristan kanina, masasabi ko to ay element din ni curly P. But can somebody reiterate bakit pwede ko nang makonclude na si C minus A ay positive? Or kinopya ko lang ba yan dahil yan yung nasa WTS? So dapat makonclude ko na element yan ni P. Para lang ma-black box, sabihin ko na yan. So if the step is very crucial, like this one, okay? Ito yung gusto kong i-prove. Hindi niyo pwedeng sabihin basta-basta na C minus A is an element of P, black box na. Kasi kailangan ko yung reason. Kasi baka nakita niyo lang, ayun yung nasa WTS, so kokopyahin ko na yan. So papatulong ko kay Matthew. Matthew, ano yung reason? Bakit ko nasabi na si C minus A ay positive?
Gaya po ng sinabi ni Tristan kanina, yung A11 ata yun na since nag-add tayo ng dalawang, yung B minus A which is an element of P, tapos yung C minus B which is also an element of P. Sabi sa A11, when you add two elements na, two
Positive real
two
numbers.
positive real numbers, you still end up with a positive real number. Kaya masasabi natin na C minus A is a element of a positive real number.
All right, perfect. That's perfect, Matthew. Thank you. So yeah, si B minus A positive, si C minus B A positive. When I add them, I will get C minus A. Then A11 tells us by hook or by crook, C minus A should be a positive real number as well. Yun yung property ng set of positive real numbers. And by definition of less than, we can say that A is less than C as desired. Okay, end of proof. Okay? So ngayon, pwede na natin gamitin yung transitivity ng less than relation. Okay? So I hope that's clear. I think that's fun. I enjoyed writing that proof and thank you for participating. Yung pala hindi ako nag-upload to my new students. I do not upload the annotated notes. So kung ano yung naka-canvas na lecture notes, yun na yung materials niyo. So you can screenshot the slide right now before I delete it, or you can go back to the recording later and then pause it at the particular moment you're interested with. But I strongly suggest, if you can, mag-take notes kayo habang nagdi-discuss. Kung sa bagay, yung iba, mas gusto na nakikinig lang sila. Minsan ganun ako, gusto ko lang nakikinig. Tapos hindi ako nagsusulat. Gusto ko maintindihan yung sinasabi ng professor ko. But after ng klase, if I am preparing for an exam, what I do is I try to rewrite everything. And then I will read what I wrote. And kasi naniniwala ako dun sa pamahiin ba yun? Pero meron yata itong scientific basis na the more senses you involve in studying, mas madali yung recall or mas madali mo siyang naiintindihan. Pero it makes sense logically. Kasi halimbawa, nagbabasa lang ako silently. Ang gumagana lang yung mata ko. So, pag mag-exam na ako, makakaalala lang yung mata ko. Why not add another sense? Halimbawa, mouth naman, papaganahin ko rin yung bibig ko, babasahin ko siya. So, ibig sabihin, dalawa na yung gumagana. Eyes and mouth. Tapos, habang binabasa ko siya aloud, naririnig ko rin siya sa tatlong senses na yung gumagana. And then, i-rewrite ko pa siya or babasahin ko siya habang sinusulat ko siya or isusulat ko siya tapos babasahin ko siya aloud. Pati yung muscle memory ko, kasama ko na para maalala yung dinidiscuss ko or yung kailangan ko sa exam. So usually, yun yung study habits ko, study techniques ko. Kaya hindi ako masayang roommate kasi maingay ako pagka nagre-review. Alright? So yeah, that's it. So I hope that gave you some time to screenshot this. So delete ko na siya. And probably I can now try to prove this one. This is kind of interesting kasi this is something that we know from elementary. Siguro ito yung kauna-unang example ng less than relation ng grade 2 tayo or grade 1 tayo na ang 0 ay less than 1. Kasi si 0, yung wala, mas maliit kesa dun sa iisa. So dapat yung symbol mo nakanganga dun sa 1. Di ba? Ganun siya ituturo sa elementary. But we didn't ask our teacher, why is that so? Why is 0 less than 1? Siguro kung tinanong tayo nun, mababatukan tayo ng teacher natin or something, alright? Pero now, we need to demand a proof. Why is 0 less than 1? Okay? Now, let's try to prove it. This is a seemingly very, very clear or very obvious result, but usually the obvious ones are the hard to prove, okay? Now, we can try a direct proof here. Because kaya lang, if we want to show that 0 is less than 1, then that's equivalent to showing that 1 minus 0, okay, is a positive real number, all right? Pero ano ba si 1 minus 0? Si 1 minus 0 ay equal kay 1 plus negative 0. Actually, yeah, 1 plus negative 0, magiging 1 plus 0, magiging equal kay 1. So if we want to show that 0 is greater than 1, then we need to show that 1 is a positive real number. But the problem there is wala tayong operational way pa para makita or para ma-check kung si 1 talaga ay positive. Kasi hindi pa natin alam yung membership ng set curly P. All right? And actually, this statement, the first half of Theorem 1.5.6 is the stepping stone para maggamit natin yung mga results na alam natin about less than, para magamit na rin natin yung konsepto ng mga positive numbers at saka mga negative numbers, as I will discuss later. Okay? So a direct proof seems to be problematic, and I hope you see why. That's why, kung hindi gagana yung direct proof, magta-try ako ng indirect proof, and it will prove that the proof by contradiction is actually an easier route to establish that 0 is less than 1. Okay? Again, so proof by contradiction, we will suppose the negation of the statement. So if we will not accept that 0 is less than 1, then we are saying that 0 is greater than or equal to 1. Okay? But this is equivalent to, thus, okay, either 0 equals 1 or 0 is greater than 1. Dalawang cases lang naman. Ito yung ibig sabihin ng greater than or equal to, right? But we already know that 0 is not equal to 1. Again, dun sa introduction ko kaninang recall, sinabi na natin na si 0 ay different from 1. Magkaiba yung additive at saka yung multiplicative identities. All right? So meron tayong P or Q, pero hindi totoo si P dahil or ito, dapat totoo si Q. Ano ang tawag sa rule na yun? Does anyone remember? Ano yung tawag sa rule na yun? Kapag ka meron ka naka-or, tapos false yung isa dun sa dalawa, sure tayo na true na yung kabila. Tandaan niyo yung term? Dugsungan mo ng konti, Tristan. Nice try though. Disjunction. Okay? Yung disjunction, siya yung or. Ito yung isang example ng disjunction. Yes, Jonathan?
Modus tollens po ba?
Yeah, pwede siyang modus tollens kung as a rule of inference mo siya titingnan, right? So, kung meron kang P or Q, pero meron ka ng not P, modus tollens, ibig sabihin, totoo dapat si Q. GN is also right if you will be just thinking about it as a proposition, okay? You can think of it as a disjunctive syllogism. Hindi pala proposition. Rule of inference din ng disjunctive syllogism. So yeah, that's another term for it. Some will say law of excluded middle, pero yeah, konting push pa, pwedeng gamitin yung law of excluded middle. But those three concepts will tell us na dahil si 0 ay hindi equal kay 1, then we can say that the other plausible case is that 0 is greater than 1. Okay? So, eto na lang. So, eto yung hahanapan natin ng contradiction. Saan kaya tayo dadalhin ng assumption na si 0 ay greater than 1? Well, I cannot do much about it but apply the definition of greater than. All right? So, remember, in other words, we know that 0 is greater than 1. So, that's the same as 1 less than 0. So, that's the same as 0 minus 1, which is equal to -1 by A3, all right, is a positive real number. Okay? Kasi nga, si 0 ay greater than 1, so ibig sabihin si 0 minus 1 dapat ay positive. So 0 minus 1 happens to be -1. Now we are saying that if the statement is false or if the theorem is false, then -1 is a positive real number. Or the additive inverse of 1 is positive. Okay? Now, you might be tempted to say that this is a contradiction already, but it is not. Okay? Kasi hindi nga natin alam na si 1 ay positive. Yun yung gusto nating i-prove. So, wala tayong basis to conclude that -1 cannot be a positive real number. Kasi baka nga naman si -1 pala yung positive base dun sa mga definition natin at hindi si +1. So, there is no contradiction yet because -1 can be the positive number and the 1 could be the negative number, right? Actually, binabasa ko siya na -1, but I mean, it's the additive inverse of 1. All right? Okay. So I hope you got that, or you get that, why I cannot say that this is a contradiction. So kailangan ko pa siyang hanapan ng contradiction. Now, can anybody help me here? So, isang step bago tayo makapunta dun sa contradiction. Sige, clue. Kukunti pa lang yung alam natin about being positive. Actually, dadalawa pa yung alam natin or tatlo kasama yung Theorem 1.5.1. So ano kaya yung pwede kong gawin ngayon? Ang alam natin, si -1 ay positive. Eh ano ngayon kung si -1 ay positive? Sige, 30 seconds para mag-isip. Higup lang ako ng kape. All right. Any suggestion? Any wild guess? Malay nyo, tama? Or doon tayo dadalhin? All right. Walang hula. So, ito yung trick. Okay? So, si negative 1, oh yes, Gian.
Ay, hello sir.
Hi.
Sir, hindi ako sure.
Sige
Pero, nasa isip ko po is, if we introduce, kunyari A, then itatry kunwari i-apply sa A11. Tapos, pag binag-multiply siya, then, yung A and the, ay, joke lang, wala pa lang. So, hindi pa po balik, pagka binultiply ang negative 1. Sir, given na po ba na pag binultiply ang isang real number sa negative 1 ay negative A? Or sir, hindi pa po? Okay. Never mind, sir.
Kasi hindi pa natin alam kung ano yung itsura talaga ni negative 1. But you're on the right track though. Gusto kong magamit si A11. Pero sige, Gian. Ano ba yung sabi ni A11? Sige nga.
Sir, if A is an element of curly P and B is an element of curly P, then A plus B is an element of curly P and AB is an element of curly P.
Alright. So, yun yung tama. Yun yung sabi niya. In particular, you were talking about multiplication kanina. Sige, magmumultiply ako, sir, ng A. Kaya lang, yung gusto mong i-multiply na A ay real number, wala tayong additional assumption doon. Pero, may kilala na ako na positive according to our argument. Kilala ko na si negative 1 to be positive. So, ano kaya? Kilala ko na si negative 1 ay positive. So, madudulas na ako eh. Ayokong ituloy. Yes, Tristan, can you help us out?
Sir, since negative 1 is positive, so yung pwede po natin siya i-multiply sa sarili niya and dapat positive po yung maging sagot. Tama po ba? By A11 po.
Alright, that's perfect. Yeah, tama, Tristan. Thank you. Kasi si negative 1, alam na natin ay positive. So si negative 1 times negative 1, okay, ay positive. Alright, so alam po na ito ay positive kasi product siya ng dalawang positive numbers, si negative 1 at saka yung sarili niya. Kaya lang, baka pala related to dun sa tanong ni Gian kanina kung ano yung mangyayari rito. But we have Theorem 1.3.5. Balikan nga natin. Tama ba yung pagkakalala ko? 1.3.5. Kailangan ko mag-scroll up. Okay. Okay, there we go. Theorem 1.3.5. Sabi ng Theorem 1.3.5, pag nag-multiply tayo ng additive inverse ni A at saka additive inverse ni B, equal siya lamang sa product ni A at saka ni B. So here we'll just take A and B to be both equal to 1. Okay? Kung sila ay parehas equal kay 1, so we'll have additive inverse of 1 times additive inverse of 1, which is what we have, or what Tristan suggested earlier. We just multiply the additive inverse of 1 to itself. And then the product, according to Theorem 1.3.5, is it's the product of A and B. So ibig sabihin, yung product ng multiplicative, ng additive inverse ni 1 at saka additive inverse ni 1 ay equal sa 1 times 1. But the identity property of multiplication, which is A 5, 6, 7, A7, sabi ni A7, multiplicative identity nga si 1. So you multiply it to anything, you get the real number back. So ang sagot pa rin ay 1. So here we get, okay, let me scroll down. Okay, this is equal to 1. And so 1, being the product of two positive numbers, is still a positive number. But here, I can draw the Harry Potter symbol, or yung blitzkrieg, indicating that there is a contradiction. Now, what's the contradiction there? Just to make it clear. Yes, Charles?
Sir, negative 1 is yung negative 1 is positive po and 1 is positive.
Right. Which violates what rule?
Yung trichotomy action, sir.
Okay, perfect. So that means Yeah, maybe I should write that down. So -1 and 1 are both positive, which contradicts the trichotomy axiom A10. Tama ba? A10 yung title niya. Yeah, A10. All right. So that proves that 0 is greater than 1. Sorry, 0 is less than 1. So that means if 0 is less than 1, that means that 1 minus 0, which is equal to 1, ay positive. So ngayon, nakuha na natin yung kauna-unahan nating positive number. Si 1 ay isang positive number. And we are sure of that right now. Okay? Now, I will assume that we have already proven the other statements in this theorem because that will be the basis. Paano natin conclude or paano natin ma-check kung ang isang real number talaga ay positive o hindi. All right? So I'll give you 10 seconds to screenshot this if you need. Okay? Tapos illustrate ko lang mabilis some examples kung kailan natin masasabi or ma-check kung positive nga bang isang number o hindi. Okay? All right. Now, paano makakuha pa ng mga positive numbers? So we know that 1 is positive right away. Okay? So si 1 plus 1 by Piano's axioms na unfortunately wala tayong time para daanan pero nagawa na to sa Math 101. Ang 1 plus 1 ay successor ni 1 and our symbol for the successor of 1 is 2. And 2 being the sum of two positive numbers is also positive. Okay? So si 2, alam natin siya ay positive na. And then Theorem 7 tells us that if you have a positive number, kasi alam na natin ngayon, pag greater than 0, ibig sabihin positive yon kasi a minus 0 is equal to a. It's an element of P, right? So if a is greater than 0, statement 7 tells us that its multiplicative inverse is also positive. So that means this will imply that 1/2 is also positive. Okay, kasi siya yung multiplicative inverse ni 2. And then 2 and 1/2 are both positive real numbers. So therefore their sum, 2 plus 1 over 2, which is 5/2, is also positive. Okay? Tapos dahil positive si 5/2, si negative 5/2 ay hindi siya positive by trichotomy action. All right? Yes, Gian, do you have a question?
Ay, sir, naiwan ko lang po itata yung reason ko kanina.
All right, no worries. That's fine. Okay? So, yun. So, dito natin makukuha yung pagiging positive at pagiging negative with the statements in Theorem 1.5. Now, for irrational numbers, it might be a little difficult, pero siguro may mga intermediate results pa na kailangan before we can say that, halimbawa, pi is positive, all right? But for now, we can now assume the usual order relations that we know from elementary. So pwede nyo nang gamitin ngayon without proof na si 3 ay positive, na si 5 ay positive, na si negative pi ay negative. So pwede nyo na uling gamitin yung mga natutunan natin about less than from elementary. But I hope you appreciated how we get there. Paano tayo nakapunta or paano na-invento yung mga positive at saka mga negative numbers na yan. And the nice thing about that, the very powerful or the fascinating thing about that is yung buong order relations na yun, na less than greater than, were brought about by axioms A1 hanggang A11. So 11 assumptions na buo natin hanggang dun sa pagko-compare ng mga real numbers. Okay? So here, just a remark here. This property number 2 is usually the trichotomy action that we know. Actually, the proof of statement 2 here is just a restatement of the trichotomy axiom. So, ibig sabihin, kaya mong i-prove yung trichotomy axiom using Theorem 1.5.2 and vice versa. So, they can be interchanged. So, pwedeng si 1.5.2 ang gamitin nating trichotomy axiom. All right, instead of A10. Okay, But I like A10 better because it's minimalist, because I don't have to define the less than relation before defining A10 or before stating the trichotomy action. That's why I'm going to stick with A10 to be involving the set of positive real numbers muna. Tapos theorem na lang etong trichotomy action na ito siguro yung ginagamit natin sa algebra. Okay? All right, and then I hope that's clear. I'm gonna jump to absolute values right now. A barrage of definitions and theorems again. Pero ito naman ay mga usual things na. Dadaanan na lang natin siya ng pahapyaw. The absolute value of a number A, parang A na nakakulong sa loob ng dalawang absolute value bars or dalawang vertical lines, ay equal lamang kay A kung si A ay positive. Now, look at the sudden change in my language. Now I can say whenever I see A greater than or equal to 0, I can say that A is positive. Because now being positive or being negative is now well defined for us. Okay? So it is equal to A if A is non-negative actually, kasi A greater than or equal to 0. Or it is the additive inverse, or I can now freely say it's negative A if A is negative. Okay, so usual absolute value definition. And then from this definition and possibly using some of the previous results that we have, we can prove theorem 1.6, which are statements involving absolute value. Statement number 1, the absolute value of a product is equal to the product of absolute values. Okay, that's a very neat result. Statement 2 is the triangle inequality. The absolute value of a sum is always smaller than or equal to the sum of absolute values. Okay. There are various proofs of the triangle inequality. Pero if I say ask you to prove it as part of your homework, then you need to write a proof using only the results that we have. Huwag kayong pupunta sa internet, nakita nyo lang sa search nyo proof of the triangle inequality. Medyo kamasmaslasan nyo, there would be hundreds, if not thousands, of proofs for the triangle inequality, but not all of them are acceptable for Math 155. Because again, the meta-axiom of ignorance prevents us from using outside results. So kung hahanap kayo ng proof, dapat siguraduhin nyo na ang ginamit lang dun sa proof ay yung mga na-prove na natin before, o yung mga definitions o mga axioms natin. All right? So better yet, try to start writing it on your own. Try to canvas all of those results that you already have and write your proof based on those. Okay. Now, statement 3 is another version of, actually, this is the version of the triangle inequality whenever there's a negative sign involved in the middle instead of a positive sign. Okay. So try to come up with a proof of these statements. Who knows? Maybe that would be your homework for Monday. So try nyo paglaruan yan kung bored na kayo. But I will not write the proof for that. Okay. And then tingnan rin natin yung intervals. Okay. So we will adopt the usual standard the standard notations for intervals. So we'll use brackets for close interval. So bracket AB means this would be the set of all real numbers between A and B inclusive. Kasama si A at saka si B. Whenever you have a real number in an interval notation that has a bracket beside it, that means kasama yung number na yon dun sa set. And you see now, this is well defined kasi alam na natin paano nagwo-work yung less than or equal to. All right? And then we call this a closed interval. Probably you are wondering why we call it a closed interval. It would be clearer when we go to closed sets. Makikita nyo na mga closed intervals ay examples ng mga closed sets. Kaya siya tinawag na closed interval. Closed siya, yung closed ay adjective. Adjective siya nung interval. I-define natin later ano yung ibig sabihin para maging closed siya. Hindi lang mga intervals ang closed. Merong mga sets na closed din. Tingnan natin siya later. Similarly, we have open intervals. So we use parentheses to denote that the number beside the parenthesis is not part of the set. So the open interval AB is the set of all real numbers that are strictly between A and B. Hindi kasama si A, hindi rin kasama si B. And it's an open interval. It's called an open interval for a reason. Example siya ng isang open set. We will learn towards the end of the section or the unit ano yung ibig sabihin ng open set. Okay, but these are example of open sets. And then we have the set A to positive infinity. This is an unbounded interval kasi nga infinity yung nasa kanan. So ito yung lahat ng numbers na mas malaki kaysa kay A. Si A ay hindi kasali. Siyempre si infinity hindi siya kasali kasi hindi naman siya real number. Okay? And then we have the half, or actually this closed interval, A to positive infinity, kasama naman si A. And then we will adopt the usual notation for the half open, half closed intervals like these, all right? And then yung kabaliktaran naman ng mga infinite intervals. Okay? So yun, I think we have most of the definitions out of our way. So na-miss nyo na siguro mag-prove. So tingnan natin yung lemma 1.1. Oh, by the way, are you guys familiar with lemmas? Kung ano yung ibig sabihin ng lemma? Okay, yung lemma o yung mga lemma or lemata or lemmas, sila yung mga theorems din sila, mga statements din sila. Pero the value of these theorems or these statements are, they are very useful in proving other results. So usually sila yung ginagamit para mag-prove ng mas malalaking theorem. So these are, you can think of it as tools na pwede mong gamitin paulit-ulit in order to prove other theorems. Lemma siya kasi palagi siyang ginagamit or may mga sikat na theorem na gumagamit sa kanya. And Theorem 1.1 will be useful until the end of the semester. So tandaan natin ito yung lemma na yun. Okay? Tapos meron pa tayong tinatawag na corollaries. Corollaries are direct consequences of theorems. So theorem pa rin siya. Pero ang significance niya kasi ay anak siya ng isang theorem. So yun yung pinaka-selling point ng isang corollary. Okay? Tapos theorem usual statements. Okay? Now, what is this result telling us? So it's telling us that if we have two real numbers A and B, and if we know for sure that A is less than or equal to B plus epsilon for whatever epsilon greater than 0 you think of, then we are sure that A is less than or equal to B. So sinasabi ng theorem na to, kapag kasigurado tayo na kapag ka si B, dinagdagan ko lang ng kahit na anong positive real number however small it is, usual to sa math. Kapag ka nakakita kayo ng epsilon, usually epsilon denotes a very small number. So the value of the epsilon is infinitesimal. So laging symbol natin siya para sa mga maliliit na numbers. So with that in mind, pwede nating interpret to as kapag ka daw si B, dinagdagan ko ng kahit anong maliit na number or kahit katiting na real number, tapos mas malaki yung sum na yon kesa kay A, then we are sure that in the beginning, A is less than or equal to B. Okay? So if we add a very small number to B and we get a number that is greater than or equal to A, then we should be sure, or we can be sure, that A is less than or equal to B. Okay? Kasi nga, konting-konti nga lang yung dinagdag mo kay B, mas malaki na siya or equal kay A. So without that small added number, then A is still less than or equal to B. And this is a very powerful result. The key there is the quantifier for all. Pag there exists lang yan, hindi na totoo yung theorem. Pero kung totoo ito sa lahat, then that's the time we can conclude na kahit wala si epsilon, kahit wag mo na siyang dagdagan, greater than or equal na siya kay A. Okay? So let's try to write a proof here. The proof is done by contradiction. It's already in the notes. So let's try to dissect the proof and look at the details here. So this is a proof by contradiction. Now we are trying to prove P implying Q by contradiction. Okay? And remember the negation. So di ba ina-assume natin na mali yung theorem. So ini-negate natin ito. So yung negation niya ay magiging P implying not Q. Alright? So gusto nating ipakita na yung P implying not Q is false. Right? So in our proof, in proving conditional statements via contradiction, you can assume the antecedent. So pwede mong gamitin yung premise. I-assume mo siya ay totoo. Kunwari, ang A ay less than or equal kay B plus epsilon for whatever epsilon greater than 0. Then we want to show that assuming that A is greater than B will create some contradictions. Okay? And that's what is done in the proof. So again, I am assuming the antecedent. Kunwari, totoo siya. Tapos, kunwari, mali yung theorem o mali yung conclusion. Kunwari, si A ay greater than kay B. And then, let's try to say it. Now, meron tayong premise. Totoo daw to sa lahat ng epsilon. Pero kapag in-assume natin that A is greater than B, then that means A minus B over 2 is also positive. Okay? Kasi nga si A daw ay greater than B, so that means A minus B is positive. By definition of greater than, okay? So si A minus B ay positive, pero itong guy na to, pwede ko siyang isulat as A minus B times the multiplicative inverse of 1/2. Alam na natin, multiplicative inverse of 2. Alam na natin na si 2 ay positive. By Theorem 1.5, si 1/2 ay positive din. Si A minus B ay positive by assumption times another positive number. We get another positive number. Okay? So that means, indeed, A minus B is positive. Dahil positive siya, pwede siyang mag-serve as my epsilon. Kasi I can take epsilon to be equal to any positive number. And why not try A minus B over 2 as our epsilon? And try to see if there would be a contradiction there. Okay? Now, let's see how we can do that. So, according to our assumption, or to the antecedent of the conditional statement, si A daw is less than or equal to B plus epsilon. But epsilon is any number greater than 0. We have shown that A minus B is greater than 0, so it can serve as our epsilon. So replacing epsilon by A minus B over 2 will give us this. The sum being greater than or equal to A. Pero pag sinimplify mo to, gamitin mo yung addition properties. Remember, payag na ako ngayon na mag-usual arithmetic kayo. Hindi na kailangan dumaan sa lahat ng mga axioms before. Pwede nyo lang gawin yung usual addition. Okay? Simplify this, you're gonna get A plus B over 2. Okay? But the statement is saying that this is less than A. So kung duda kayo or hindi clear sa inyo na tama yung sinulat nung textbook, sige, himayin natin tong A plus B over 2. So meron kang A plus B over 2, tapos magiging less than yan sa A plus A over 2. Bakit? Kasi si A ay mas malaki kay B. So si A ay mas malaki kay B, so ibig sabihin, pag pinalitan ko si B ng A, yung makukuha kong bagong number ay mas malaki. Or kung talagang axiomatic na kayo ngayon mag-isip, pwede ka mag-start dito, A greater than B, then I can use the addition property of inequality. I'll have A plus A greater than A plus B. Okay? Gumamit na rin ako ng commutativity ng addition along the way. And then one of our theorems in Theorem 1.5 tells us that we can multiply both sides by a positive number. So I'm multiplying by the inverse of 2, which is positive. And hence we get this. Sorry, mali pala. What should have I done here? Tama pala. A plus B over 2 nga pala yung pinakompare ko. So essentially, yeah, A plus B over 2 is smaller than A plus A over 2. But A plus A over 2 is equal to A. So essentially, this last inequality is true. So in summary, what we have here from this line is that A, that guy, is strictly less than A. Kasi ito, posible maging equal dito. Posible maging equal dito, pero ito, sigurado tayong mas maliit kay A. So in summary, what we have in this line is that A is strictly less than A, which is a contradiction. All right? So a number is not less than itself. Mabaviolate niya yung trichotomy action, right? Because A is equal to itself, so it cannot be less than itself, nor can it be greater than itself. Okay? So that's a contradiction. So that means this supposition is false. So we are forced to accept that A is less than or equal to B as claimed. Right? So end of proof. All right. So any questions? All right. So no questions. Probably I'll I'll use the last 2 or 3 minutes introducing ordered fields. Mabilis lang to bago tayo magpunta ng completeness section, but that would be for Thursday na. So kahit anong set, any non-empty set, together with 2 binary operations that satisfies A1 to A11. Na-satisfy niya yung field axioms, na-satisfy niya yung ordered axioms. Ang tawag natin dun sa system na yon, the non-empty set, together with the 2 binary operations, we call them an ordered field. Field siya kasi na-satisfy niya yung A1 hanggang A9. Dahil na-satisfy niya rin yung A10 at A11, isa siyang ordered field. Okay? So examples of ordered fields definitely are, kasi nga tinailor fit natin yung definition ng addition at multiplication para maging ordered field, si R, para masatisfy yung A1 to A11. But there are smaller sets that are also ordered fields. Halimbawa si Q. You can check that Q is a field kasi masasatisfy niya yung A1 hanggang A11 hanggang A9. Tapos ordered din siya. May inherit niya sa pagiging ordered ng set R. So Q is another example of an ordered field. So merong mga sets na mas maliit kay R na ordered fields din, specifically Q. But there are also sets larger than Q but smaller than R that are also ordered fields. But before going there, let's just take note that finite fields are not ordered fields. So at least dapat infinite yung laman ng set mo para magkaroon siya ng chance na maging ordered field. Okay? Now, nice question is there a set between Q and R that is an ordered field? Okay? Now, the answer is yes. Meron pang isang set sa pagitan ni Q at saka ni R na isang ordered field. Ang tawag natin sa kanya ay set of algebraic real numbers. So, para maging algebraic ang isang number, ang isang real number, dapat makahanap ka ng polynomial equation, all right, such as of this form, where all the coefficients are integers, okay, na equal kay 0. Kung saan solution yung number na yan. So kung ang isang real number ay solution ng isang polynomial equation with integer coefficients, then siya ay isang algebraic number. For instance, 1 is an algebraic number because it is the solution to the polynomial equation x minus 1 equals 0. Negative 1 is another algebraic number because it is a solution of the polynomial equation x plus 1 equals 0. 2/3 is an algebraic real number because it is the solution of 3x minus 2 equals 0. Tama ba? 2/3 ang solution. Yes. So si 2/3 ay algebraic number. Actually, in general, all rational numbers are algebraic because all rational numbers or a rational number m over n is a solution of the equation nx minus m equals 0, right? So yung mga m over n, solution siya lagi ng nx minus m, where m and n are integers. So this is a valid polynomial equation with integer coefficients. Ang solution niya ay m over n. So definitely lahat ng rational numbers ay algebraic numbers. But there are some algebraic numbers that are not rational. So for instance, square root of 2. Si square root of 2 ay solution ng 2 minus x squared equals 0. So this is a polynomial equation with integer coefficients. Pag sinolve mo yan, ang sagot ay x equals plus or minus square root of 2. But we have proven earlier that square root of 2 is not a rational number. So therefore, merong mga algebraic numbers like square root of 2 na hindi rational. So yung set of algebraic numbers ay mas malaki kaysa kay Q. Pero meron din naman mga real numbers na hindi algebraic. For instance, si pi at saka si e. I think the golden ratio is also a transcendental number. Pero kailangan ko yung i-check. Para safe, si pi at saka si e, sila naman yung mga numbers na irrational din, kaya lang hindi sila algebraic. You cannot find a polynomial equation with integer coefficients na sila yung solution. Oops, sorry. Na sila yung solution. So definitely, yung set of all algebraic numbers ay mas maliit kay R, ay subset ni R kasi hindi lahat ng real numbers ay algebraic. But the set of all real algebraic numbers is another ordered field. Okay? Now, what is so special about R, aside from being so far the largest algebraic ordered field that we have? Oh, by the way, the set of complex numbers is not an ordered field because there is no ordering para sa mga complex numbers. So aside from being the largest ordered field, ano pa yung special with the set of all real numbers? Well, that would be the completeness axiom. So kasi kompleto na yung set of all real numbers. Kasi di ba nakita natin si Q, hindi pa siya kompleto kasi si square root of 2 ay hindi rational. Pero ano yung ibig sabihin para masabi natin na complete na ang isang set? Kailangan nating bigyan ng definition, what does it mean to be complete? Hindi pwedeng tulad lang sa buhay na napaka-abstract or relative ng term na complete. Kailan tayo nakokompleto as a person? Pero sa math, dapat lahat naka-lay down yung definition. So next meeting, we will define what it takes for a set to be complete. Ano yung kailangan property na masatisfy niya. Alright? So, and then that will set the set of real numbers apart from all other ordered fields. Kaya mas maganda mag-work kay set of all real numbers kasi kompleto na siya in the sense of completeness na i-define natin next time. Tapos lahat ng desirable properties na gusto natin para mag-hold yung calculus ay naka set of all real numbers na. Okay? And that's where we will start on Thursday. Okay? So any questions for today before we leave? Sorry, 4 minutes over time. Okay. All right, so I guess there are no questions. So I hope you got something from today. Those who recited kindly, those who recited verbally, kindly put down a comment dun sa chat natin. Ana, susulat na kita. Sino pa ba? I think, sige, wala nang guest na nag-recite, no? So yon. Drop down a comment para matali ko siya later. All right. So with that, thank you guys for joining me today. Enjoy the rest of the afternoon or of the day. And then let's see each other again on Thursday. Stay safe, guys. Bye-bye.